Hi everyone. Today we will discuss DBMS, which is nothing but database management system. DBMS it's actually a software that deals with databases, handling the databases. And here database is nothing but that stores the data. Now if you can see an website, suppose this is a website which I have designed. If I am here adding the bus details, suppose here 200 seats to express Delhi, ending point Bombay, so that the data which I entered in the front end, it will reflect in the back end, so that the data it comes the front end to stored at the back end part. So so basically the data here, if you check an website, the data which you're entering at the front end, it will connect to the back end and it will store in the database. Let's discuss now why we need database. Suppose to store and data, we have already have file management system, right? In our Windows or like Windows, like we can store data. But why the database we needed explicitly is for the security purpose, for the integrity purpose, for the efficiency, and for the concurrency. Our class or the different types of databases. Suppose there is a relational databases like uh, Postgres, MySQL. Also, there is a non-relational databases like MongoDB, DocumentDB, like those. Now, let's discuss in relational databases. We will have like basically the data will be in the form of tables, and inside we'll have columns, and we'll insert data like the records. It's more like an if you see an Excel sheet, it will looks like that. So let's discuss some few concepts here. What is the super key? So for an each record, let's take this example. Suppose you have the table. If you want to find the super key, we will take here the column such that gives the unique identification of that record. So we can see is name, address, phone. We can take customer ID, so that it will be the super key. It will give unique importance of that record. Super key can tells us uh, details details of the record particularly. Super key can be many, but if you talk about key should be one and only, and that gives the uh, that should represent the whole record. Suppose if you take here the authors table with author ID, first name, last name, and books table with book ID something, which attribute is the primary key? If you talk about the ID can be the primary key because the ID can tell all other details. And even if you talk about here the bus list, if I go to the Postgres, there can be IDs 2, 3. So 2 is the primary key and 3 is the primary key of this record. So if there is an two tables and each table have its own primary key, if the primary key of other tables is present in the first table, we can called it as foreign key. It will we will discuss this in uh, when we're talking about joinings. Discuss very important concept, SQL queries. SQL means structured query language, primarily used for to get the details from the database or retrieving the data from the database. It is an case insensitive. Suppose if you see here the details of the bus in the Postgres, if you want the all the details from the bus, we can simply use select star from the table. So it will retrieve all the details of the bus tables. And if you want here, like we can use the where condition. Like if you use here select star from the table numbers, where if you want the particular condition we can use even that. Like if you see here, if you want only details where endpoint is equal to 4, then we can write here like where endpoint is equal to 4. I'll run this query. So like it is select star from bus where endpoint it is an so as it is an char, we should use the char. Like endpoint and starting point, I gave string data type. So basically, there can be a few more details on this. Like there is an create a database query you can create, and create table, and inside you will give its fields like the columns and their types. Then when you create the table, if you want the details of the particular record, we can use select operator. So select star from the table name. Let's try one more example exercise here. If we have the details here, it is asking to fetch the names of the customer where that are not referred by customer ID, not ID is not equal to 1 or 2. That means if you write select, uh, you should select the names column only from uh, the table name is customer, right, where id is not is equal to 1 or 2. So if you test this, uh, so yeah, our output is wrong. We should select the name. So they are the hacker rank and lead code test. We can even practice there. So basically what they are asking is select the names, that is all the names, uh, name from the customer table where id id is not equal to 1 or 2. Oh, actually that is the referrer id. We should take the names as it is. So where the referrer id is not equal to 1 or 2. So like this, we have some crud operations. Like the select is actually nothing but get the details, get that all the details. Like it is like an viewing all the details, and then we have uh, add the details. Like that is nothing but insert into it will be like table name, and then values. So it is basically post the details, and we have uh, update the details, update the table, update query, and we have deleting the table. So that is nothing but delete query. So I can show here. If you see in the front end, there is an we can update the details, we can delete the details, and then we can add the details. So the same thing we can do here in the database also. Then after that, CRUD operations, there is one important concept called uh, joining. Joins. Joins is like kind of there will be like table one and there will be like table two. So if you observe here in the table one, if we need we have the foreign key from the table two, so we are just adding the all the details of the table one, table two, and we'll get the respective information. So I'll show here. Suppose there is an given and one example. Here we have the employees table and the department table details. So what they're asking is just to selecting an employee department first name, last name, job ID, and department name. So if you can see here, this is an schema design. Schema design. It is nothing but the design of the relationships, like all the tables required we can design here. So what they're asking is uh, find the details of the employees who work in the human resources human resources department. And suppose there is an department id, the department id, this department will be joined together, and there we need to find the human resources thing. So for that we will use joining, like the selecting details, and from the employees it is an alias, we are doing inner join from departments on e dot department id, that is d dot department. So we're joining the column attribute where the department name is human resources, and order by, it is actually to print the details in the ascending order. There's some of the things like can learn in w3 schools as well. Then we here we have like of joins. The normal join is nothing but inner join. So the common attribute values only it will print. If you do the left join, it will print all the values of the left side. The corresponding right side will it will show null, and the right join it's just opposite of it. And the self join sometimes we will use is quite of interesting. If you watch here, it's like they're asking the details of the employees who join the company before their managers joins the company. So that means if you can see here, every employee can be one manager, right? So the employee the data the employee, suppose they have they have one manager id, so that manager id can be like same with the employee id. So we will self join this both columns such that, so the self join can be used like this way, so that the manager id it is an foreign key kind of itself to the employee id. Discuss now uh, aggre- aggregate queries. Aggregate query is nothing but we will use like if we want like average, count, or like the total value of the that particular column, you'll use the aggregate query. It will followed by group id. If you can see at the example, we need the details, uh, get the details of average salary of the employee for each department. So we need to print average salary of the each department. So I'm printing the department id. After that, the average of aggregate function as an alias of the salary from employees, and I'm grouping by they're asking each department wise I'm grouping. Then order by is normal, ascending, or descending. So whenever we use group by, it should not follow by where, it should be followed by have condition if we need any kind of conditions we want to write. Discuss now subqueries. Subqueries are nothing but query inside an query. So it can alternate joinings one also. Like we can see here, we need to print the details of the employees who didn't work in any job in the past. So I'm taking details select star from the employee such that where employee ID should not in again I'm selecting the employee ID from job history where from the job history ordered by the employee ID. So that's it. So that's it. I'm printing the details I'm printing the all details of employee where employee ID should not be in an employee ID from the job history. Like that, we can use multiple queries here. Let's discuss some concepts like indexing. Indexing nothing but when there is an millions of data, we will use indexing so that it will just easy to retrieve. Also, there is one more concept, transactions. If you observe when you are doing net banking, it's very important that we should follow both sides. The transaction should occur, the sender and the receiver. So transaction is like kind of grouping of one or more SQL statements that can interact with an database. Transaction is entirely unlike an it's a logical or complete unit of SQL statements together. Then at last we have like schema design. Schema design is it's like how data is organized within the relational database. These are like logical constraints, like we will discuss about fields, data types, relationship between entities. So for this, so the schema design, it's like if you when you're working on project, if you get like you will get like the problem statement, functional requirements, then to design. So there the database you should only design. So the ER diagram it should be like where we can have the login, the fields, admin fields like booking, customer, feedback, all the modules like or the kind of entities inside we can have the fields, and they're mapping together like one to one, many to one, like kind of. And the class diagram also will be the same like this. So they can be like the sequence diagram, they can be like activity diagrams, all those things.